Question 4 is an optimization question, and you really need to draw yourself a little sketch of this cuboid to begin with. This cuboid's got a square cross-section that's x and x, and it's got a height of h. So the volume of this thing is x squared times by h. And we've been told that the volume of this thing is 1,000. And so h is 1,000 divided by x squared. Now the surface area of this is made up of a few parts. First of all, there's an x squared on the top, but there's also an x squared on the bottom. So my surface area has got 2x squareds to it. But then I've got this rectangle here, which is xh, and there's 4 of those all the way around the outside. So I've got 4xh there. So 2x squareds plus 4 times x, and h, well h is what we had earlier here. H is 1,000 over x squared. So my total surface area is 2x squareds, 4 times 1,000 is 4,000, and we've got x divided by x squared, which gives an x on the bottom, and there's the surface area that we were asked to show. We're now trying to find a minimum, trying to find x for which the surface area is minimum, and so we need to differentiate that thing. So if I'm differentiating surface area with respect to x, differentiating this gives me the 4x. This bit here, of course, is 4,000 x to the power of minus 1. So differentiated, that one makes minus 4,000 x to the power of minus 2. At the minimum, the gradient of this is equal to 0. So I've got 0 equals, and again I'm just going to switch here to the different format because I think it will be easy to solve the equation if I write it like that. Again, grab your calculator if you want to. I'm going to times the x cubed up there. I'm also going to divide by 4, and I think I've got an answer of x is equal to 10 here. X is equal to 10 when I've got the minimum. There's only the one answer, so I'm not going to go on and do a second derivative to check it's a minimum. The fact that there's only the one answer there, I think that gives me x is equal to 10 as our answer.